also, when we get to fabric, like doping fabric, they call it, you need to know in the bias direction of your cloth is going to be the most flexible. And why would it be the most flexible? All my rovings are going this way and this way. And so the bias is 45 degrees to that. Okay, so if you're trying to bend fiber around corners and things like that, it doesn't like to bend on a straight, if this is it, it doesn't like to bend 90. Whereas if you go a 45, it kind of goes up and over the edge a lot easier. It's not a true 90. Okay, so pay attention to your bias. Think about that when you're, building your bridge, things like that. But these things here are definitely in your writtens. Okay, they ask about that. Here is fiberglass. So standard fiberglass. One thing that you'll notice is that there's tape around the outside edge. Okay? In critical situations where you need that weave to be perfect, okay, we will tape a square and then we will cut out on that tape because that holds all your fibers together and doesn't let them go. You're probably not going to do that for just our standard thing because all we're looking for is something a little bigger than our patch, and we don't really care, and we just hack out fiberglass, and it might destroy the weave a little bit, but with fiberglass you can actually kind of get it back. You can massage it back into place and get it where you want it. But this is just a standard fiberglass. All right, fiberglass, E-glass. I don't know why we call it electric glass, but high electrical resistance. It's cheap. E-glass is what we're going to be using. That's what we have. That's what all you'll ever need to use in the cowlings and the wheel pants, things that you're going to repair is standard E-glass. Okay? When you want stronger, stiffer, and tougher, more expensive glass for actual structural repairs, you're going to go to the S-glass. Okay? These two things will be in your writtens. Okay? They ask you all kinds of goofy questions about that. Fiberglass is often used for secondary structures, fairings, wingtips, radomes. Often it's used in gliders and cirruses and things like that. It's all used in that. Main advantage is significantly lower cost than other materials. Way lower than Kevlar, way lower than carbon fiber, way lower than boron and ceramic. Okay? Remember, boron and ceramic are the only people that can afford that as the military. Okay, so there's our word again, the aramid, the Kevlar. That's a Dow Corning. They came up with it. So technically, I think they still have the rights to it or something, so they're the only people that can build it or something, or they give rights out. But Kevlar is yellowish, typically yellowish in its natural state. Like I said, you can buy all different kinds of colors of Kevlar. You can buy orange, red, blue, green, all these different, cool colors and they always mix them with carbon. So you have that, the blue black, the green black, things like that. Let's see, DuPont. Did I say DuPont or DuPont? DuPont. Kevlar, excellent tensile strength and toughness, poor compressive strength compared to carbon. High resistance to impact damage, that's important. Okay, high resistance. Lower stiffness density and cost than carbon. Special tools are required to cut and drill it. Yes, I hate working with Kevlar. Okay, you get like 5 minutes of brand new sandpaper on your little whiz wheel and you have to change it out because otherwise it leaves little fuzzies everywhere. Okay, and it doesn't cut very good. Okay, it's a royal pain, especially when I'm working with it and you're trying to cut it with scissors. You have to have the best scissors. You go steal them from grandma got the best scissors. Just don't let her know that you got them. And then, and you can cut your Kevlar out fairly well, okay? I've tried using a razor blade with it. Your razor blade might work for the first inch and a half, and then it dulls right up, and you're toast. So, one disadvantage is Kevlar can absorb significant amounts of water. Yeah, that's a problem. Okay. I think that's why we mix it all the time. We never just go straight Kevlar. The reason we go Kevlar is if we mix it with carbon is because of the high resistance to impact damage, because carbon doesn't like impacts. Anybody's ever watched hockey, takes a shot on the stick and goes to use it again, and it's just completely broken, because that impact will fracture that carbon pretty quick. So this is a picture of carbon fiber. Carbon fiber, I've never seen anything other than black, so you know. Advanced oh yeah, the reason these are blue is because I'm going to whip through this really quick. There's your boron and ceramic. Interestingly enough here, certain can retain most of its strength and flexibility up to 2200 degrees. Holy moly. Okay? You may as well just put a big dollar sign in front of that thing, because that's where it's at. So, boron, hazardous to work with. Big surprise. Okay? So is carbon fiber a little bit, but it's not too bad. We have downdraft tables. If you don't know what those are, they are in the welding room. It sucks all the air down. We try not to breathe it as much as possible. That was one more. Often used in firewalls. Perfect. Carbon graphite. Okay, there is a difference between carbon and graphite. You need to go to page 7-6. Figure it out. I don't deal with that stuff. Carbon is corrosive to aluminum. We already talked about that. And special care must be taken to prevent corrosion when they're bonded together. All right, let's go to the next one. Fabric weaves. Okay, yeah, you need to know this because there is a lab on this. Okay. There's two different weaves: plain weave and satin weave. Plain weave, over, under, right? Just like standard grandma doing the knitting or something. You remember the old thing where they run the little, slide the thing over, pull it up, shove the little loom, loom thing, do it. Everything is over, under. Okay, that's standard, that's plain weave. Satin weave is tricky because it's like an over, under. Okay? It's like two. They'll go over twice and then under once. Okay? The interesting thing about that, so I had this is some carbon fiber that I purchased, and I don't know if you can see that, but they sell carbon fiber with different, so it's like an octagon look to it. Okay? So like on my boat, I did a bunch of stuff that had the octagon weave in it, okay, just because it's cool. It's cool, but it's not as worth the amount of time it takes to do it. But, so anyways, this is the octagon, and so this would actually be a satin weave, okay? And the reason it's a satin weave is because it's over and then under, and then finally over again in the right spot to create the hexagon thingy, okay? So that would be a satin weave. And when you go to do your lab, okay, where you have to identify the weaves, you really got to look at some of that stuff, okay? Because they don't do it because they're nice. They do it because they're trying to trick you into not knowing what weave
Is it a specific number of overs and unders or any random assortment to get the design they want?
To get the design they want, yes.
Is the design any way structural or have to do with
I
strength?
actually don't know why. I think it's only for visuals.
Okay.
I can't see it being for anything else because fiber runs, the fiber's running the same length. It's still transferring the energy from that side to that side and from that side to that side. Whether it's going, over, under, over, under, over, whatever it's doing, it's still transferring that energy. So I think it has more to do with the actual visual.
On the slide it says it must be draped into complex shapes.
Let's see, where does it say that?
The bottom dash set.
High degree of smoothness. Interesting. I have not experienced that. Just because if I have to do something like that, I'm always running under bias.
Yeah.
I'm trying to think if most common satin is carbon. But I do know they have it in the fiberglass too. But it would probably only be in the S class, not the E class. E class is just econo-glass. The stuff we're gonna use is just straight, plain weave. So yeah, that's interesting. So they must use it when they need to do, when they're putting their Bugatti carbon fiber car together, blah, blah, whatever that is. Yeah.
So Kevlar absorbs a lot of water. Does the water break down Kevlar, make it weaker?
I actually don't know that, whether it does it or not. Yeah, I actually don't know. I mean, obviously, if it says it absorbs water, that's bad, because that means weight is gonna change. And I wouldn't think the strength would stay the same if it absorbed water. But I mean, you saw how fine that weave was. I mean, yeah, I don't know. I don't deal with Kevlar a lot. Like, I've never actually repaired anything with Kevlar in it. I will send that down the road to somebody that wants to, pull their hair. Okay, I'll do fiberglass, and actually I've never done a carbon fiber. I will send that out too, just because of the inspectability. I really don't know what I'm looking at when it comes to carbon fiber, because inspecting carbon fiber that's black, you can't use the ways that we are gonna use to inspect our fiberglass piece. The one guy that I knew that he was heavy into it, he did all kinds of carbon fiber glider repairs. He'd take it back till he knew he had ground all the damage away, okay? And he'd automatically go another 6 inches. He'd extend every repair, he'd take right to the end of the crack, go another 6 inches, because you can't tell if it's debonded back in there. So kinda like this here when I was, so if you can see this was a 22 hit, and here, let me get this. You can see on here how far it delaminated, okay, underneath and back in.
Would it get mill into it with one material?
Yeah. So with carbon, the damage might stop here that you can physically see, but that delamination can go farther. And so that's why I don't like messing with carbon fibers. Unless, of course, it was a wheel pan. I wouldn't have any problem doing that. But if I was, reattaching a wing attach point, I'd send that one down the road. Okay, here's your over-unders. I know.
Does this come into play with the lab?
Yeah. Well, this is in your book. But I mean, I've got a whole just an example of, these are all, everything with this one here is, that's the plain weave one. Everything else is satin. So the second it does 2 overs and an under, it's an automatic satin. Just keep that in mind. If it's over, under, basic, plain weave, as soon as one of them goes over twice, it's an automatic satin. Okay. So fabric weave, let's go to hybrid cloth here. Okay, so this is the Kevlar carbon fiber. Looking at this right here, is this going to be a satin or a plain weave? It's going to be satin. And the reason is, it's an over, under, over. And so it doesn't just go standard over. Now this might be kind of interesting because every single one goes over 2 and under 2. So would that technically be a plain weave? I mean, but according to what everything I've read, as soon as it doesn't go over and under every single time, it's automatic a satin weave. Okay? So where you'll find this most, this is a glider. I was doing inspection this past summer and I'm like, oh, I gotta take a picture of this. So the whole fuselage, and this is underneath, this is the brake reservoir, so this is where the pilot sits. So basically the entire glider is built Kevlar carbon fiber, okay? In the cockpit area, wait a minute, yes, in the cockpit area. And the reason is we have more durability, impact damage, right? We wanna save the pilot. We wanna keep him safe, okay? So if we look aft in this glider, oh, here, let me do this. If we look aft in this glider, this is all carbon, so this is looking straight down the tail. You can see as the tail leaves and goes away, you can see this is just a Kevlar piece, okay? Carbon, and then it looks like there's some more Kevlar that runs back and kind of V's in the top there. They probably needed that Kevlar just for possible save the pilot thing, you know. They wanted to say, hey, let's really keep the pilot safe, you know, in a roll, you know, if he goes in upside down or something, you know, something strange. But you can see down here, this actually looks more glass than Kevlar, fiberglass. But this is definitely Kevlar, the yellows. This might be a Kevlar glass mix, who knows what that is. But you can see the difference. This is all carbon fiber bulkheads and things, okay? And they're all just glued together. All right, next slide. Okay, so now that we've talked about fabrics, this was in the old one. Okay, so there you go. The matrix. There's 2 types of bonding. Okay. There's 2 types. There's thermoplastic resins and thermal setting resins. Okay, we are only going to deal with thermal setting resins. Thermal setting resins means it basically takes heat, things like that. Chemical reaction creates heat, which then actually hardens our stuff. It's chemical and heat related. Whereas a thermoplastic is, you're going to have to read about it. I've never ever used thermoplastic. Okay, it's made for more interior pieces, things like that, and it can be reheated, moved around, and all kinds of weird things can happen to it. Okay. Resin is the heart of the composite material. Okay, there we go. The primary purpose of resin is to transfer loads from one fiber to another and hold the fibers in position. All resins require a catalyst or hardener to turn them from a liquid into a solid. The specific ratio of resin to catalyst required to not underestimate that statement. Okay? When you are only allowed a certain percent of error on resin. Okay? So when you're mixing your resin and you're stirring it too fast and you splash out some resin onto the table, you have no idea if you splashed out hardener or resin onto the table. It gets de-sixed. Grab the next one. And you don't screw it up the next time. Okay? If you get the structural resin, MGS resin, you're talking $350 a gallon. Okay? And that's not even buying the hardener yet. The hardener is almost as expensive. Okay, so for you to do a standard repair on something, you're gonna have $500 just into supplies, okay, before you even start the project. Okay, it's expensive. So be very careful on the specific ratio of resin to catalyst, okay? We have scales out there, and you will put it on a scale, you'll pour the resin in, you'll record. I always have a pad of paper right beside it, and I write down the number of resin I've got on the scale, tear the scale out, do my math on my phone, calculate how much hardener I need, add my hardener, okay, and then be done with it. And then mix it thoroughly. Mix very thoroughly. Get the bottoms of the cup, the corners, the edges. I always tell everybody when you're done, take your cup, set it on your box, verify it gets hard, okay? If you screw up the ratio, that will tell you. And also the other thing that I make people do is try to take the cup off of the resin after it's gotten hard. And if it's sticky on the outside and never hardened between the cup and your block of resin, that means you didn't mix it correctly. You didn't grab all the edges and make sure that was fully mixed together. Okay? So get used to being very thorough on mixing. Okay? They're going to ask you a lot. I mean, my high schoolers love this, you know. It's one thing that they never forgot, you know, pot life, because that was a question that was always on the test. It's the specific time in which a catalyzed resin must be used and can vary as little as 15 minutes to as long as 8 hours. Okay? That is your pot life. Okay? According to the FAA, this is also in your tests and stuff. The ratio of fiber to resin matrix for the greatest strength is 60-40. Okay? 60 fiber, 40 resin. That is the ultimate goal. And as we get into repairing our things, I will show you different ways of trying to achieve this mixture, because inevitably it's so easy to go 60-80. Okay? And as soon as you do that, it's brittle, okay? And it weighs too much. What? Okay. Thermal setting. Let me just go to all of it so I can see everything that needs to happen. Okay, thermal setting resins cures into a permanent state after the application of heat. Oh, and I was, yeah. So anyways, you're gonna be doing a bunch of labs, and there's gonna be a lot of these questions. I don't know if I have to necessarily read all this, so just take a second and read that. You just need to know that there's two types of resins out there. Okay? We are only going to be dealing with one kind, and we're going to be dealing with thermal setting resins. And I will flip the page here. to be polyester resin. That's the most common resin, that's the first resin they ever came out with, okay? Polyester resin does not care how much hardener you throw in it, okay? You want it to cure quickly, add more resin, okay? The Barent Seabolt, the guy that came over from Germany, we actually, one of our gliders broke, and it was cheaper for us to fly him over from Germany and pay him for a 2-week vacation, okay? And pay him to fix our glider and fly him home than it was to have it repaired in the US. Okay? It was cheaper to do that. And he was a funny guy, because he says at the back of the hangar, because they use polyester resin to attach things to the floor. Like if they're gonna build a jig, you know, when he came over to fix that glider, he built all these goofy mounts that held the glider in place, because it was completely broken in half, right? So he built all these plywood things, put them on the floor, used polyester resin and a bunch of flocks, we'll get into that, and he glued all these things to the floor, okay? And then he was able to then build the glider up by placing it and lining it up and getting it perfect before he put it back together. But he said at the back of the shop where he works in Germany, there's these big bins, the big concrete bins. And he goes, every single day, someone is running to the back of the shop with a burning thing of resin because they wanted it to cure as fast as possible, okay? And polyester resin will catch on fire, okay? And he says every day, someone's running to the back of the shop and heaving this burning, you know, can of resin into their big concrete burner things that, you know, sits and burns up, and it's made specifically for that, okay? Because polyester resin doesn't care. It generates its own heat from the chemical reaction. It's relatively inexpensive, fast cure times. You can do all kinds of things with it. What I hate about it is it's sticky. Okay, after so long, the resin gets really sticky. Okay, so well, let me show you a picture of it. This is fiberglass resin, the stuff you can get from the auto parts store. I know I got all the things done. Used in boats and cars. It's not used in structural aircraft components. Okay? Has limited use in non-structural aircraft components. And one thing that you need to remember. Wait, more polyester? We already went over all this. Why? Okay. So this is more about polyester resin. Carefully measured, blah, 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 and it won't harden too much, and you can start a fire. A matrix with too much hardener is brittle and subject to crazing. Okay? I mean, there's many times you get and look at the last of your resin, and it's all boiled up and nasty and cracked, and it's bad. Also, doing a repair with a large repair with polyester resin, use several short strips of cloth rather than one large piece. I have tried to do some molds with polyester resin, and the heat produced, it makes bubbles, and it just makes this huge mess. It's horrible. Okay? After that, I said never again. I'm just going to use the new stuff, which is. Oh wait, it is not this. This is other weird stuff before we get to the real stuff. This is stuff, and the reason I put the little asterisks up there, I will never use this, ever. I doubt you will ever use this. It's possible you might, because over at the SMAT LLC, they were asking about repairing the air box coming off the 172, and that, I think, possibly might be boron. The air box, because it's like a dark brown color. repair it, they will probably have to use something like this. It's either that or they send it out, have someone else repair it and bring it back. But it's possible that these type of resins, they might actually use, but I highly doubt it. That brings us to epoxy resin. Okay, this is what we're gonna be using. This is the industry standard, okay? Epoxy resin. It gives us time to work, okay? The West System resin that we're using, you don't get as much time as some other types of resins. But, you know, so I'd be careful with how big of a batch you're actually going to make, okay? If you can cool it down, it will slow the process down and give you more working time, okay? So if you think you're gonna spend an hour laying up your bridge, you're wrong. Because you're gonna have to mix 2 batches, okay, to be able to get this thing done. Epoxy resins harden through a process known as cross-linking rather than the chemical reaction of resin and hardener, okay? This is very important. The resin to hardener ratio is extremely critical, okay, in epoxy resins. Keep that in mind. Usually takes longer to cure, and usually takes extra heat for the final cure. So if you guys get your bridges done in time, cook them. Find out what the West System manual wants you to do, how long they want you to cook. Even a couple hours of cooking will strengthen your project, okay? That's if you get done. Let's see, many different types of epoxy. Very important to check with the manufacturers and to make sure you have the correct resin, okay? When you're dealing with resins from, or airplanes from other countries, it's rare that they will tell you that you're allowed to use American resin. Okay? It is very rare. Okay? So make sure you understand the resin that you need and make sure you're fully aware, and hopefully you guys can do math and figure out, you know, when they give you a ratio, how to figure out how to make sure you have the right partner. Yeah.
Do we do that by weight, or is it like by pump? The measuring out rate?
You were doing it by weight. Okay? I'm not a fan of the pumps. Even though if it was a marine industry, I wouldn't have a problem with it. If it's gonna be West System and I'm putting it on something that I want structurally sound, I will actually weigh it out. I will make sure that it's weighed correctly. And I kinda like the West System, but if you gave me a choice to use the other epoxy that I like is an MGS resin. If you gave me the choice to use MGS or West System, I would pick the MGS every time. I just like the longer working time that I get from the MGS because I can add slow hardener or fast hardener, or I can mix a combination of those two to get a certain amount of time. If you use slow hardener with MGS, tomorrow morning after you get back here, it's not gonna be hard yet. It has that much of a working time that, you know, it's so fast. Whereas this West System stuff, you lay it up in the morning, you might even be able to start grinding on it later in the afternoon. You know. But grinding on resin that's not fully cured, not a good idea. High strength, very stable structure, low levels of volatiles, excellent adhesion, low shrinkage, good chemical resistance, ease of processing. I also need to note one thing that's very, very important. You can repair polyester resin projects with epoxy. You may not repair epoxy resins with polyester. You can only go the one way. And so if it's in doubt whether your piece that you are gonna try to fix was made with polyester or epoxy, what are you gonna repair it with? cares if it was polyester? You can always go over polyester with epoxy. You can never go the other direction. Disadvantages, can be very brittle. Too much resin is brittle. Can lose a lot of their positive properties if there is excessive moisture during the curing process. This is important. Can also have reduced properties if moisture is introduced into the final composite. Okay? We stay away from that. This also brings me to say that you need to make sure that you never blow off your project with shop air. Okay? Air has oil in it when you blow it off. If you contaminate what you're trying to glue, it will not work. It will, yeah. You stay away from that. You can use a vacuum, use acetone, whatever you gotta do to clean it, but never use shop air. Alright, so there's that asterisk again. Okay, quickly read that. Okay, good. Curing stages of resin. Okay, there's gonna be questions on this too. You're gonna wanna know something about this. Thermosetting resin, use the chemical reaction between the resin and hardener to cure. There are 3 curing stages. A stage, B stage, and C stage. They've been mixed, but the chemical reaction hasn't started yet. There are some paints out there, that epoxy paints, that you have to mix and let sit for 15 minutes before you're allowed to shoot them, okay, on paints. It's kind of the same way with resins, but I feel that it activates a lot quicker, and I haven't seen where it says you have to let it sit in resins before, especially in the West resin, it doesn't say that. But there might be some resins out there that actually say you've got to let it sit for 10 minutes to let it activate before you're allowed to use it. So make sure you read your manual good. B stage, components have been mixed, chemical reaction has started, material has thickened and become tacky. Pre-preg materials are in B stage. We haven't even talked about pre-preg, thank goodness yet. C stage, the resin is fully cured. Some resins cure at room temperature, but may require elevated temperatures to fully cure. Okay, some resins require that. In order to get the maximum TGs out of that resin, you have to cook it. MGS is a good example of that. That resin, you really need to cook it. Oh, more of this. Okay, so thermoplastic. I can't say that word. Semolene. I'm just gonna miss all the crystal in the middle. Good flame resistance, primary and secondary, often used with carbon aromatic glass, so it's used with everything. Woo-hoo. Available as injection molding compounds, compression moldable sheets, tapes, and pre-preg sheets.
Matt, question. The second to last word on that slide, how do you pronounce it, and what does it mean?
Pre-preg?
Pre-preg, like pre.
We haven't even gotten into that. Pre-preg is it's actually kinda cool. When you purchase your fabric, it comes with the resin in it. It is frozen.
How does it not melt?
It gets shipped in frozen containers, and you have to somehow then keep it in the freezer or in the fridge or something stupid, because it only activates when you bring it up to temperature. Okay? This is for places that have, people of lesser intelligence, and don't know how to mix resin right, but in all fairness, they want the 60-40, okay? Because it comes 60-40. You can't add more, and you can't take away. So it comes already set up to be the best possible thing that there is. Okay, and then they cut it, do whatever they gotta do, put it in all their little compression molds, slam them all together, throw them in the autoclave, pops out, pop their piece out, trim it, and it's good to go. You know, but it's expensive. And you gotta keep it, you know, at a certain temperature. You can't just let it sit at room temperature. So there's a lot that has to be done with that stuff. And we'll watch a video on that here, of them building parts with pre-preg, so you guys have an idea what pre-preg materials actually are, and, stuff like that. Like the X-22, whatever is that the fighter, the latest fighter? Whatever the latest fighter has carbon wings, and it's all built with pre-preg. 35 maybe, that's it. Yeah, I think it's all carbon fiber wings, and it's all pre-preg materials. And that's because, you know, the military can afford stuff like that, right? You know, the common person can't, you know, unless you're buying a $1 million sports car. So this is more stuff that you will never, ever see. I've never encountered any of this anywhere, but I really haven't been too far outside of the general aviation world, right? You know, I haven't been down to, you know, the wonderful world of Gulfstream, or, you know, some fancy Airbus or Boeing facility or anything like that. I'm sure in some of those they might have this stuff, and if they do, they're gonna teach you how to use this stuff, okay? But you're gonna have to dig through your manuals when you go to do your labs, because I think some labs they talk about some of this stuff. All right, we're gonna take a break before we go on to this. Because we actually get to look at some of the products. What do we use? It's not clay. That is resin mixed with micro balloons. It's called micro balloon. And every one of my high schoolers are like, can I try to break it? Go ahead.
The walls,
It just bounces.
the drywall is gone.
It's crazy. I mean, feel how light that is. Wasn't it crazy light?
Yeah, it was. I was like,
So light.
do you have a picture of your boat? You talk so much about it. I want to see it.
What time you going back?
Spring I'll have it.
Okay. Around here?
Let's get back in 5 minutes. Come on, we can do a 5 minutes, because we gotta get out and break our stuff. Speaking of that, I gotta get Nick to give me some. When the snow melts and the ice is gone, I'll have it all over the place.
Nice.
But I do have a couple.
It's a wake boat, right? No?
No, it's a bass boat.
Oh,
We bass fish.
it's like carbon fiber tends to get thrown around on
So-
wake boats all the time.
You also have to think about the load on this.
Yeah.
The load
What was the last thing I did on my boat?
is in the center. I'm not gonna tell you my design, but
Randall?
Uh-oh.
Keep this passing down.
We're gonna be passing it around.
I have an idea in my head. I know what I'm doing.
Merry Christmas.
Let's do my group. Still
You didn't break it.
No, I didn't. I was trying to bounce it. Not a good bounce.
it's kind of lame. No, yeah.
Does it have an arrow pointing at this rectangle?
That's just my overall strength. We're just going for section.
Zero idea.
1800 to 1.
Is there food?
No, it's just like,
There's some of them have film in the middle. So
Crazy.
where does that hatred come from? Where's it
this
from?
one's 470.
Carpentry.
You were in carpentry?
Yeah.
Oh,
When you do siding, you have to put like a layer of foam on the back, and I was always cutting out these nonsense shapes, like, like, I hate it. Hate it. Me and that multi-tool all day.
They don't even know where it breaks. It's
how long were you in construction?
2 years?
Did you like it? I guess not.
Not really. It's only because it was my dad's company. It's not his, but he was like a supervisor in the company. It's like that puts a bad rep on your name if you're the child of the supervisor.
Yeah, probably.
I had to build my reputation from rock bottom.
No, never.
Where on earth did these go?
What?
Where did they go on the plane?
These are the bridges.
totally
They're
something.
These are just bridges to show like
Like-
strength of fiberglass. We
yeah.
can make these.
I
So-
didn't know if there was like a part on the plane.
No, these are bridges. So, see why there's a hole in the middle in all of these? You put the weight in the middle, and then both these on the edge of each other. And then, it's written how much weight that one held. This one held 424 pounds. And this one held 358. This one held 474.
That must have been good.
This one held 210, which is nothing. Now,
Wait, don't they have to
try
try
to.
certain lengths?
Yeah, that's
bro.
Oh, this is Leon City.
I think there was a
Who?
max.
This is the best design.
That one did go the farthest of
Nope.
the ones that broke.
This,
This
well, there's a different one.
474.
Yeah, 474. That one I did the best. This one only did 4.
But yeah, it's because it's just one giant reinforcement. You might as well just connect it to. Yeah.
It's a lot of fun. I like these.
It's not a saw chips.
It could be. It's polishing the cardboard.
I'm debating if I text my engineer friend to ask me to design this.
You need to clean up Rich.
What? That's true. Triangles are the most favored shape in physics.
I-beams, U-beams, or
Oh,
triangles?
this was smart. It's bowed just a little bit.
Nice.
That's smart.
Question is it an in bow or an out bow?
I'm thinking of like, you know how, no, you were there for it, but he said he was gonna try and like,
Then it would push down.
he was gonna try and take multiple pieces of fiber, string, and I was like, could you do like braces inside your, like.
But you're also going for like,
Yeah, but string. It's literally like this, like fiber, carbon fiber, rolled together.
I did say something about that yesterday.
Yeah.
And then it pointed me and said big guys.
Yeah. Ouch. I'm so sorry. Why is that ouch? That is another way of passive aggressively calling someone fat. Fun fact.
I'm pretty sure his point was just, they weren't like people, you can be big and not fat, or heavy and not fat.
Just call me fat.
Just straight up say I'm fat, little bro. No. It was more the class was.
People are so sensitive up north.
No, it's sarcasm. It's all sarcasm. This entire class is sarcasm.
Okay, there's a lot more sarcasm out there.
It was the class
a lot of
tugging his chain instead.
Welcome to Michigan.
Like, it's only a
Everyone's
fact
pretty
that
much
somebody who's 6'8" is gonna be bigger and heavier than somebody who's 5'5".
With your carbon fiber? Yeah, you saw what I did, I just yanked out the fibers, like on this one here. I just dismantled the, I mean, originally I stuck it in the drill.
Matt, are you patenting that?
What's that?
Are you patenting that once you get it success?
If it's good, I see, I can't not be good.
What if you braid
I
it?
mean, look at it. If I spin it that hard, feel how hard that is.
Dang.
You know better. You know?
Yeah.
When you put a 60-40 resin mixture in that, whoa.
What if you braid it?
Okay, so I did too. Well, I was thinking of that, like when the matrix is gonna hold it where I want it anyway.
Yeah.
So it's so much easier to use that.
Gotta find like strength rate.
Because I think what I need to do is, I need to resin it like this.
And
Because
then,
to get resin inside there, I don't know if I'll get it in there. Then I can wrap it just to make sure that I have resin in it. Because if I go to a 60-20 inside of there, it negates the fact that it's practice. I have to have,
You know all about that, I don't wanna make
it has to be saturated.
yeah.
just like,
All right, so let's talk about thixotropic agents. Okay, thixotropic agents means that you're just gonna thicken it up. Okay, all right. There's a bunch of different styles. There's two of these here, flocks or milled fibers are structural. A lot of times these are structural things, so you can actually use it to glue things together. In fact, remember in the picture on the glider, looking at the tail section, it had those Kevlar pieces. They use resin with milled fibers mixed together in there to glue those ribs into the fuselage. Okay, that's what they use to bond them in. Okay, and I have some right here. You don't have to be nearly as careful with this stuff as you do microblading. Here you go. Just don't dump the back out. This is the one that you have to be careful. Let me find it. You guys are gonna see.
Mystery cabinet.
So you can, that's flocks. And this these are microbloons. Don't drop this. Put your finger in it. You can get them on your finger. This is how small the microbloons are. Yeah, these are little glass spheres. They're round. And woe be to the person that dumps microbloons on the cement floor. You've all seen Home Alone, right? Oh. Okay, it is glass. I mean, it is the slipperiest thing you've ever experienced when you dump microbloons on the floor. Carpet's not a problem. We got guys that'll vacuum it up. Okay? Microbloons it just makes everything glass. Funny story, I knew the guy that used to be the sandblaster here in Ionia, and they said, hey, can you sandblast the water tower? And he's like, he goes up to the water tower and he's like, yeah, I can probably sandblast this. This is not a problem. And he figures out, he gets his harness out there and he gets all his rig out there and he gets all the way up on top of there. And he hit his trigger and he said, and I thought I was going to die. Because as soon as you put sand down, a
nice, big, huge, sloping away thing, okay? He's like, I thought I was dead, man, you know,
At least he
'cause
had his
he's,
harness.
he's like, trying to figure out, what do I do now? You know, I can't move, you know, everywhere I step is just, you know, my feet go right out from underneath me. Yeah, he says he'd never do that again. But micro balloons, be careful, if you wanna pull the Home Alone thing, you know, you can, you know, sprinkle that everywhere, and, I mean, it'll lay you out. So, it's actually crazy because it actually pours like water. It's crazy, it just kinda, you're just like, what?
Does it have dimensions on how small those balloons are?
I mean, you saw how, I mean, it's dust. I mean, you notice how careful I am with this bag? Because if I go like this, it just like poof. I mean, and they're really small, and they're going all over the place. So micro balloons, tiny glass balloons that are used as a filler, and here, pass this around, Isaiah. That's a ball of micro balloons. And that, like I said, all my high schoolers, can I break it? And I'm like, yeah, throw it around, do whatever you wanna do. Nobody's ever broken it yet. I'm sure if you guys put it in a press, you could probably crush it. But when you put resin with it, I mean, that's how light it is. So as far as aviation goes, we want micro balloons. You know, if we make a repair and the repair's heavy, that's a problem. Okay, we never wanna add weight. When we go to do our wheel pant repair, you guys will be weighing your wheel pant, okay? And then you're gonna do your repair, and you're gonna weigh it again, see if you gained any weight. Okay, that's one of the things you're gonna do. It lowers the density of the resin matrix, yes, it definitely does that. Alright, so we are gonna go to. Okay, so let's talk about how this, let me do, okay. There are 4 ways that we manufacture and we repair composites. The standard way is a wet layup. That's what we are gonna be doing, okay, for our wheel pant repair. That's a standard way that you're gonna repair something. You can vacuum bag. Typically, like my son down at Gulfstream, they call it vacuum bagging. Basically, when there's a damage to the portion of a wing or something, they can suck down the pressure. It'll actually suck it down, flatten it out. They have a thermal blanket that goes on there, okay, that does the heat cure, okay. And I've got a couple cool videos here coming up. I just can't see when it's coming up. But they will do that to repair spoilers, things like that are composite on the Gulfstreams. So wet layup and vacuum bagging are kind of the same thing because we typically do a wet layup. Wet layup means I basically put my resin down, put my fiberglass into it, and then I saturate it, and then I can take it to my piece and then suck it down with the vacuum bag. Okay, that's what you're gonna do on your bridge. You're gonna use vacuum bagging techniques to be able to build that bridge. Okay, we'll have a table. I think there's 6 stations on the table that everybody will be able to have their own valve and things, and we'll go over that probably next week sometime in detail before we actually get to the vacuum bagging, because there's a lot of little things you have to know before you just jump right in and attempt to vacuum bag. I attempted to do some vacuum bagging, and did we agitate it a little much? There was a smoke plume coming up there.
What's it taste like?
Doesn't taste like anything. But I mean, if you breathe it in, it's not, I mean, what's it gonna do to you? You're just gonna end up coughing it out, you know? I mean, you'll be adding your own matrix to the microballoon.
Pull it hard.
The other thing is injection molding. What they'll do is they'll put all the glass in their mold, okay, they put everything together, and then they've got a tube that goes into a big vat of resin, okay, and they apply a suction at the other end. Resin comes out and actually goes in and actually fills the entire, your project with resin, and then sucks it down and holds it there, okay? When I first started doing my own vacuum bagging, I forgot to tell you this, before the smoke cleaning, I didn't know how many HGs I needed to put. I thought, oh, I just put a lot of HGs. HGs are a negative vacuum pressure, right? And I think I had it up to like 10 or even more, and all it did was suck all the resin right out. So there's a magic number where you need to, that will pull it down and hold it in place versus completely destroy your part. Okay? Because it's a lot of work and a lot of consumables to do vacuum bagging. Compression molding and heat press forming, okay, that's more the pre-preg stuff, they actually put the pre-preg in there, they put it together, they clamp it together, they throw it in, it sucks it down, heats it all up, one in big fell swoop, comes out of the oven, and you're done, okay? Filament winding and protrusion. Filament winding is how they build the Boeing 787 fuselage. It sits there and spins, and it's got these, it just keeps on spinning. It adds the resin to the fiber right at the head where it comes out, and then it goes on the big spinning thing, and it puts it on exactly where the engineers have determined they want fiber. Okay? So those are the 4 manufacturing and repair of composites. Basically, this is just manufacturing. Repair is only really this top one. Okay? And that's what we're going to be doing. And hopefully when we're done, you guys will be very adept at it. Review, yes, this is review, by the way. So basically, the next little part of this is going to be,
Literally the entire slideshow twice.
yeah, see, this is review. Advanced composites, look at that carbon, you guys know everything about this now. Plain weave, hybrid cloth. Oh, here. Okay, so remember the Brixtop Tropic agents? This white band right here, you can see, that's where they glued these in, okay, using that flux and resin matrix, or resin mixture, okay? Which is kind of wild. layup and vacuum bagging, used for many repair procedures and some manufacturing procedures. The dry fabric and the resin are kept separate until the work starts, often referred to as a wet layup, which is our wheel pan, okay? Can be cured at room temperature or heated to speed up the curing process. In one of the shops that I worked at, our bathroom had electric heater. Ooh, that was amazing. Because I could take anything that I worked on and all the fiberglass products, anything that I wanted cured, I'd reach in there and I'd crank that old temperature up, and the bathroom was my, autoclave, okay? And people would go in to use the bathroom and it's 120 in there, and it was like, it was only really problematic when I had epoxy paints that were curing in there, because they'd about fall over from the fumes, okay? If you know anything about epoxy paint, do everything you can to not breathe it, okay? Epoxy paint is bad. Let's see. Okay, let's talk about vacuum bagging. Okay, vacuum bagging. Numerous items make up the vacuum bag setup. So, anytime you want to glue two pieces of fiberglass together, if you do not sand it, and you do not prep the two pieces, it will not stick together. Okay? So when manufacturing wings, let's say you're manufacturing a glider wing, and one glider wing is probably from here to that wall long, okay? And you have one half of it, and you need to glue the other half to it, you have to sand where that spar is going to go all the way to the end. You have to sand the leading edge where that leading edge is going to get glued in, and you have to sand the trailing edge where it has to be glued in. The Germans would sand it. Well, some genius American decided, this is ridiculous. I am not sanding this thing, okay? I am done with sanding this thing. There's got to be a better way to do it. And so what he came up with is he came up with a polyester fabric, which is almost identical to the fabric we put on our airplanes. It's a polyester fabric, only it's a really fine weave, and we call it peel ply, okay? Peel ply, after you put it on in the spots that you're going to have to glue something to. So when they lay up that wing, they'll put a piece of peel ply down where another piece has to be glued to it. When you're ready to glue to it, you grab that polyester fabric and you rip it off. That leaves the perfect surface to it for adhesion. Okay, so if you have to put two pieces together, you're going to use peel ply, because you can yank that peel ply off. It is now, you don't have to sand it. It is ready right now to put glue something to it. It does two things. One, it makes a surface that you can glue to, and two, it keeps all the contaminants away until you're ready to glue. Okay? In our case, on the inside of a wheel pan, what it does for us is it makes that repair so perfectly smooth, and that is what makes everybody else in the shop look at you and go, you are the king of fiberglass. Because most fiberglass repairs, who's all stuck their hand in somebody else's fiberglass repair on a sharp edge? Okay? Yeah, you reach in there and you're like, oh, whoa, and you're like, shaking the blood off, because somebody left those sharp fibers sticking out, and it can rip you up hard, okay? Peel ply prevents that from happening if you do it right, okay? And that's the most important thing that you need to learn in this whole thing, because everybody that sees you do this, they'll be like, where'd you come up with that idea, And you're like, well, it's kind of basic, in the aviation world, okay? So peel ply is a parting film, allows excess resin to flow up through it, so when we get to our appendix 1 of our repair, when you put your peel ply on, it says specifically in there without adding additional resin. Use your brush to push down and work all the bubbles and work that peel ply into your project, because that will smooth it out. It'll take excess resin out so we can get back to our 60-40, okay? Because inherently you're gonna wanna put way too much resin in there, and we'll show you how to get to, remove most of the resin, so we're good to go. It allows it to flow up through it, and it feathers the seams and fabric overlaps into a smooth surface, so nobody gets an owie, okay? Vacuum bagging also has a breather. I should just go get that tarp. Am I? We don't have another dog with that block.
Hey, who drew my name on the wall over here?
On the what?
Did you draw my name on the wall? Oh, well.
Yeah, I was ready for this.
Yeah.
On that ball? Oh, no.
On the ball that David has.
Curve.
Yeah, did that,
Guilty.
did the micro balloons ball go around?
I bet you drew it on that.
Alright, for some reason, okay, here's an example of fiberglass, right? And it's so nice and soft right now. I don't have peel ply laying here, that's weird. Peel ply's on our rack out there. Okay, so now we're into breather cloth. It absorbs excess resin squeegeed out and squeezed out, and allows airflow to the vacuum port. Okay, so what you have, this little guy here, I built a bunch of these, okay? This allows air to get sucked through this breather cloth and out to the vacuum machine, sucking everything in, because we have a vacuum bag, which is, and by the way, we're making you build vacuum bags, and someone saw these at Harbor Freight, and these are the bomb, because they're already sealed, because it is so hard to seal all the edges, okay? And this guy here, you can do a little zip thing there, and away you go. The hardest part you're gonna have is placing this in and sealing this to the bag, which we have this really cool sticky tape, okay, this yellow gooey tape that we use to seal all these pieces together. So you're gonna have two ports in this bag. One is for the suction and the other is for the gauge, because you need to monitor what pressure is and the HGs are inside there, okay? So you're gonna have two things embedded in your bag. And so that yellow was the sealant tape. We don't have a thermocouple because we're not heating it up at this point. And we don't have a heat blanket, but we do have vacuum bagging film. So there's two other things. You'll notice this one should not be given to kids, but this one could, because you can still breathe through it, right? This one here goes on top of your project, okay, allowing resin to get up through it and get into the breather cloth. Whereas this other one goes on the bottom of your project and gives you a nice flat seal surface. So if you're actually building your own vacuum bag, which you won't have to, you would use this stuff here to basically build your own vacuum bag. And let me tell you, you think you got all the holes, and you don't. It takes enormous effort. You're even gonna get your butt kicked with just two little tiny outlets, because you're gonna walk by it while it's starting to cure and you're like, where's all my pressure? Where'd it go? You know, and so you start messing with all your little tape things, and all of a sudden, boom, it'll pop back up, and you're like, oh, good, we're back up, back in business. Okay, so you do have to monitor your vacuum bag, so don't like start it at 4 o'clock and leave. You know, it needs to be started, and you need to walk by it and verify it's gonna do its thing. So let me do another quick thing here so you can see is kind of how it works. You guys won't have the heat blanket, but you will have the surface breather. Here's your perforated film and your surface bleeder. This doesn't totally mirror what we are going to do, so I'm just going to show you this because when we actually go to talk about this, I'm going to draw it on the board and show you which ones you're going to need for your project, for doing your bridge, okay? And that'll be this is just what's in your book. This is also getting into, this is your actual repair, and there's two types of ways that we do that, and we haven't quite gotten there yet. So we're going to show you a couple more pictures. When it's all said and done, this is what vacuum bagging looks like. Okay? There is a tremendous amount of waste with vacuum bagging. Okay? This is definitely not a green thing. Even though it is green, it's not a green thing. We waste so much supplies doing vacuum bagging. Okay? Let's go to it keeps it up there? See my amazing typing skills here. Queen, how do you spell it? Queen, Queens. Is that it? Yeah, I don't know. Okay, here we go.
Carbon fiber is really one of the fundamentals really to make a car strong, very light, safe and have fantastic performance. It creates massive rigidity but does not add weight, which is crucial if you want to make a really efficient, fast and fun sports car to drive. As far as we're aware, our cars are the most carbon fiber intense cars in production right now, as we have over 400 different carbon fiber pieces. This here is an intake for the engine, intake plenum. We have some pressurized turbo pipes, valve cover, and even parts like the engine, as we can see here, are made of carbon fiber, especially the parts up top on the engine to get the center of gravity low. So what we're seeing here is something as very simple as a tube. It's a turbo piping, and what I have in front of me here is a machined mold from aluminium. Even a simple detail like a tube needs a lot of thought to make it perfect. The CAD model is flow to check that the flow is perfect, that it has enough volume to pass enough air to the engine at top power levels and top RPM levels. It also has to have a shape which is strong enough and a calculated thickness of the carbon fiber so that it can take the boost pressure. You can see here that it's kind of a funky shape to it, that it's flow optimized for this curve. We have an integrated mount here for a pressure and temperature sensor. Actually, when we manufacture a carbon fiber apart from this tool, the first thing we do is to put a release agent here, because in the carbon fiber prepreg, which I have here, which is actually the material that part is made out of. It's pre-impregnated with the two-component epoxy. So if this would be put down here without release, and it would actually stick to the tool. And then this material, the carbon fiber, is cut to suit the tool part. This is not optimized for this now. I just took a small piece, but it's applied like this, layer by layer, different amount of layers depending on the need. So that's actually what's going to become the part. Then we need to pressurize. We need heat and pressure to consolidate this, to get it to have the right strength and the right properties. So in order for the rest of the process not to get the processing material not to get stuck into the carbon fiber and the epoxy, we put this kind of release film here, which is easy to tear off of the part when it's done, and it also makes sure that this breathing fabric, as it's called a breather, doesn't stick to the carbon fiber piece. And what this does, it makes sure that the pressure that this is subjected to, or the vacuum that we also suck out, that it gets spread out and that we don't get pockets of air. It's making sure the atmosphere difference is controlled over the surface. So at the end we put this bagging material over the whole part, and then we seal it off with kind of a goo that is similar to black chewing gum, I would say. So basically these are the elements included in the production of the part. And it's quite intricate, especially with a tube like this that has to then, you put carbon fiber here, we put carbon fiber here, and then these, I'll take this out right now, then they have to match together. And we need this bagging material to come into the tube to pressurize the tube from the inside, and then to seal off the tool from the outside. Of course, the thinner, the lighter, but also less strong part. So if it's a safety critical part, or like this, a pressurized part, it really needs to be calculated well to have the right amount of carbon fiber. You never want to put more carbon fiber than you need into a part, because first of all, carbon fiber is expensive, so the part becomes unnecessarily expensive. It takes more time to apply the carbon fiber than is actually needed. And in the end also the part becomes heavier, which is maybe the worst part in a super light sports car. The end result is this tube. So in the end it's a quite simple looking part, but there's a lot of thought that has gone into what it becomes in the end. Already of course from shaping the part, but also when it comes to laying it up and getting the right consolidation. You can see straight from the tool you get a quite nice even surface that doesn't require a lot of hand fettling afterwards. As it is a very complex technology, there are many types of weaves, many types of carbon fiber strands, and different philosophies how to apply them. It's a little bit of a black art really, and really lessons learned and what kind of philosophies you're working towards. But we have been developing carbon fiber parts since 1994, so I would say we have a quite good experience and can create extreme lightweight and strong parts based on the knowledge we have and the analysis tools we have. So it's really a labor-intensive process, and the persons involved in the manufacturing really needs to know what they're doing to get the desired result. Of course, here we have a much more complex part, so you can imagine what has to go into this compared to a simple tube. And what's nice about carbon fiber is you can vary the strength and thicknesses in different areas with no limit. It's just how much thought you want to put into it, and how much labor you want to put into it. But it can be so optimized, like this corner can have a little bit extra carbon, it can be thinner here, we can have a different direction. Not many other materials gives that kind of freedom. At the same time, not many other materials can soak up so much time in the production process. But that's what makes the car extreme and what it is in the end. Koenigsegg and carbon fiber are very closely integrated, and it has to be that way in this very competitive market we're in.
show you this so you understood that word, pre-preg, okay? So that's what pre-preg does. It obviously it's expensive, you have to keep it, the temperature controlled, and the only, when you wanna activate it is when you actually use it and then you put it into play. I've actually never seen pre-preg materials, okay? I've only heard about them, I've seen them in videos, so if one of you actually gets to play with pre-preg materials, you know, like I said, out of 30, maybe one of you might get to play with them, okay? It's definitely not a common thing that's out there, okay? So, interestingly, the resin allowed to advance to B stage and then kept there by freezing below zero, okay? That's the major disqualification of pre-preg in Africa, right? You're not gonna be able to ship this pre-preg material all the way over there and keep it from, you know, thawing all the way over there, so you're gonna be stuck with doing wet layups with epoxy resin out in the middle of nowhere, okay? Down in Peru with Sam Air, you know, he calls me up and he's like, okay, we punctured the float, you know, out on the river, and we're trying to figure out how to get the airplane back, you know, type of thing. You know, so at that point, you send someone out there with, you know, some epoxy resin, and you put a Band-Aid on it long enough to get home, you know. And then on 206, that's a lot of weight, a lot of water pressure, so it has to be somewhat decent enough to get home if it's not a full structural problem. If it's just a puncture, probably not gonna be a problem, you know, too big of a problem. But that's the kind of stuff that you would have to deal with. I mean, I've been out in the middle of, you know, the Canadian wilderness with a canoe, and we busted a hole through the bottom of our canoe, and you're like, okay, what are my options now? You know, because I can't paddle that fast, you know? And so we ended up going to a pine tree and finding the thickest pitch that we could find, okay? And we heated it up just a little bit to get it somewhat soft. We worked it into all the fibers, and we were able to shove those fibers back together, because the piece, it was still, all the pieces were still there. So we took the strands that did this, we coated them with all that pitch, and then we shoved them back in so they grabbed, and and it made a watertight, you know, seal, and we continued with what we needed to do, and got home safe. I did have to, you know, call the place that we rented the canoes from and confess that they're gonna have to do a Kevlar repair on the canoe, because it was, you know, fancy little Kevlar 40-pound thing, which they soaked me pretty good on the repair, so. Is that where we're at? Uh-oh, I got problems. I don't know how to get this back. Oh, there it is. Okay, so this is basically what he just went over. Is that it? Yes, that's it. So it's a very easy application, but time consuming, right? It's time consuming to put all that together and make it work. Now let's go to injection molding. Let's see. Like I was telling you before, injection molding, basically they take the part, they lay up all the fiberglass, they throw a bucket of resin at one end, they throw a tube into it, they apply a vacuum on the other end, it sucks all the resin up right through the whole, all your fiberglass out the other side, provides the vacuum bag, and away they go, okay? I have tried this once, and so using vacuum pressure to hold those inside pieces up against the piece. So it wasn't a true compression molding, okay? Whereas real compression molding is as in this next picture, okay? You take the mold, put your stuff in there, slam them together, fire it up, boom, you're done, okay? Once you get the heat, you're done. Heat press forming, which you'll never play with. Very similar compression molding. They're heated in an oven until they're pliable. The pliable sheets is quickly moved into a matched male-female die set. Applies pressure. Most of the time dies stay at room temperature, but heated dies may be used to precisely control the cool down rate of the material. One of the guys that used to fly gliders out of here, he owned Delta Tool in Detroit. They had 18 acres of buildings on their roof. They actually built I think it's the Raptor windshields. Okay? The windshields on the F-22 Raptor are 2 inches thick, acrylic. Okay? To build those and make it so it's optically sound, when you inject the acrylic into the mold, it has to be cooled down at the most optimal rate, okay? So the entire thing is cooled down super slowly and super evenly, so it has all these little ports and things that cool it down. And it's a very complex cool down procedure, but when you get all done, you actually have a window you can see through. Okay? And of course, you know, you can, because it's going to the military, you can charge any amount you want. So, he was an interesting individual. I always remember the one thing where he left for the weekend and took the car keys and forgot that they were in his pocket. And so his wife went out to use the car. The car wasn't available. So she calls up the dealer and says, I want a new car and I want it delivered and put it on Rudy's bill. So in comes the Cadillac, gets parked beside there, and Rudy paid for it just because he forgot that his keys were in his pocket. I always thought that was funny. So when you have a big company like that, you know, stuff like that can happen. All right, filament windings. I kind of told you a little bit about this, and I think there's the picture. Okay, so basically what happens, pre-preg material goes around. There's a heat source over here that actually heats it up, throws it on the mandrel. The mandrel sits there and spins, and it actually winds it up. If you want to see more of that, actually look up the 787 fuselage building. Okay, that's what they use. It's kind of cool. And if you were asking me what this is, I actually don't really know what protrusion is. That's the same thing as what we just saw. You're going to have to figure that out. I won't worry about that. Okay. Let's go to heat curing. I don't really know what hot patch bonding is. My kid sent me a picture, and I keep thinking it's coming up real soon here. But basically, it's a really fancy electronic controller that monitors the temperature, and it changes according to the schedule. I'm hoping that it's coming up really soon here. Oh, come on. Oh, it is coming up. Okay, my kid sent me this. So at Gulfstream, this was during his training. They had to set it up. So this is it's a Wichita. I'm not sure. I think that's because it's in Wichita. FYI, from Wichita. But it's got a printer. It prints out all the data, tells you exactly what temperatures it was set at. You set this all up. This is the vacuum sucking it down. This is the thermal blanket here that heats up and keeps it at a certain temperature. These are the thermocouples that go in that this reads, that then keeps that at a specified temperature. And then this is the vacuum that sucks it all down and holds it into place. And when you get done, it prints out your little receipt and tells you that, you know, you've done your repair, everything's good to go, yeehaw. Okay? So that was at school. When he left school, he sent me this video. Where's the video? Okay, so this is the system that he was using now. Okay, he had to fix a spoiler. And so this one here is actually a computer generated gizmo. You can see it's pulling it up to temperature and it's keeping it exactly, and obviously it's, you know, there's all kinds of information that he's getting. But let me go back to the beginning stuff. Okay. That is running these infrared lights. Okay, and those lights are sitting there and they're flashing to keep his repair at the desired temperature. Okay, and so it's sitting there flashing on his piece while it's curing. And this was, by the way, just a delamination. So it was just there was a delam on one of the spoiler thingies or whatever. Okay, and so he had to go in and do that. So that's basically, I'm sure this is not legal for him to, you know, send to me, but we bend the rules every now and then. So yeah, so that's just an example. You see the lights flash on and off, keep it at this desired temperature. Ooh. Can you read that in there? That would be really bad. So anyways, that's the kind of system that he gets to use now down at Gulfstream, just because he's been through the schools, and you can see that's a completely different system that he was trained on. So therefore there's, you know, there's like the Kuhns guy said, you know, it's a little bit of a black art. Okay? There's a lot of learning that goes into this stuff, a lot of reading, a lot of read the manual, figure it out, you know, and I would imagine on just on a standard spoiler delam, you know, nobody's really worried about a whole lot, you know, so it delams again, okay, put more glue in it, be done with it. Usually on a delam, yeah, you're just gonna separate it, you're gonna force glue down into it, and then glue it back together. When you're all done, you're gonna actually call in quality boys. They're gonna come in with their little ultrasonic testers and stuff like that, and they're gonna verify that it actually laminated correctly, and then they're gonna do the final sign-off. You know, so he's just gonna follow what he has to do and get it done. Break time. In fact, we're gonna do more than just break time. We're gonna do real break time. I have here your groups. What lab do you need to go to? Lab 162-11. To start this lab, we are going to go out and we are going to accomplish 1, 2, and 3. That's half the repair. Look at that. There's only 6. There's only 3 more things to do. So, as far as the groups go, do you want me to do this? That's not the right one. Really? got your groups, so you're gonna get together with your partner. Number 1, place masking tape with your name on the assigned wheel pan. Number 2, with the assistance of the instructor, damage the part. What I'm going to do is I'm actually gonna look inside your wheel pan that you have chosen and put tape on stating your name. And I'm gonna look and see where the best spot is to break these things, because, by the way, if you decide to break it where another one was, what happens is it will transfer energy and it'll pop other things off and cause your repair to be absolutely enormous. So we want to avoid that at all costs, okay? Some of you will be fortunate enough to do that. And just think you get more experience. At that point, we're gonna go damage the part. Then you're gonna weigh your part. Okay? I have a scale out there on the table. You're gonna weigh it and you're gonna record it on your paper. Okay? Once you get that damaged part, at that point, we're gonna then talk about how to go back, what our next step is, and how we're gonna determine what type of damage it is, how to inspect the damage, and like that, okay? So we're gonna take a break. You can go out there. On that table are wheel pants, 15 of them. First come, first serve. Grab what you want. Any other question?
Well, you kind of answered.
Yeah.
Okay. It's just like top and bottom of your pair also. Because what's like the one of the 2 grades? It's not like group grades.
These groups of 6 or pairs of 2, right?
Groups of 2.
Oh, yeah, okay.
And I don't know why he did the 1 through 5. I think that was because that was left over from the beginning when we only had 2 downdraft tables. And we had to rotate people through the downdraft tables, but I built another downdraft table, plus I brought mine over. So we actually have 4 downdraft tables, which is fairly enough to accommodate everybody. Especially when the fact that not everybody's gonna be in there grinding at the same time because of the different complexities of everybody's repair. Okay? So everybody's gonna have a little different time frame. It's gonna be up to you though, if the downdraft tables are all being used and the vacuums are all being used, you obviously have to do something else until a spot is available so you can get in there. Okay? Any questions? Alright, so first step, you need masking tape. And then meet me in the sheet metal shop by the big vise and bring a ball peen hammer. And this is where I wish I had my safety glasses. What did take this?
I need to plug this in first.
Carter, why don't you go work for the Kuhns 5?
What?
professional comes into you and says, yeah, I broke my wheel pant, you don't ask them how, you know, because you're gonna tell you hit it with a hammer, and you're gonna be like, what did you do there? So, these are the types of damage that we can have with fiberglass, okay? Surface damage, right? That could be, does anybody here think they have only surface damage? No, all right? Delamination, right? Delam, I know we definitely have some delams going on, okay? Fiber breakage, anybody got some of that? I'm pretty sure we got some fiber. Facing and core damage. Okay, this gets a little interesting because when they're talking about facing and core damage, that would be like in this glider wing here. If you got an impact here, the facing is damaged and the core. This is what they're talking about, this core, this PVC foam core, okay? That's core damage. Okay, so at that point, you'd have to remove the top, replace the core, and then go back in and build up a repair on top of it, okay? I know I've got a couple slides of it, a couple of that I've done. Puncture damage, both facings and core, okay? I have a picture of that also. Damage requiring replacement. So like some of these ailerons, it's not possible for you to actually fix it and keep it in balance, so you're just gonna spend the big bucks and have it shipped from Germany and be done with it. Fastener hole damage and corrosion. These are all things that we're looking for, okay? So, inspection of damage in composites. Obviously the first one is visual. You know, everybody I'm pretty sure can tell there is damage on your part, right? It's not that big of a deal. The second is a ring test, a coin tap. So everybody typically should have a quarter in their pocket, okay? And you can use a quarter to tap, and this is one of your labs too, by the way. And you can actually, let's see, did I bring those in? Oh, I didn't, they're out there still. But now, if everybody's in here doing this, it doesn't work, okay? You have to kind of find a quiet place alone so you can tell what the sound sounds like as you travel up. Okay? You have to be able to listen to that audible telling you, hey, I got to a point and there is delamination up in here. Okay? And so when we go to do the one of the labs, you're actually going to find the damage inside that piece and mark it out with a dry erase marker, okay? And then you're going to record it on your sheet, erase it, and then hand it to the next person that's going to be in line doing it. But this is the coin tap. So if you have any inclination, you think possibly you've got some damage, you know, if I'm looking at a wing and I see a dent like this, I'm going to grab this and I'm going to run across it, and I'm going to be like, oh, that's a problem. You know, because immediately I know I got problems. So this is the easiest way to detect delamination, especially from your facing to your core. Okay? You do have to be careful. If there's a rib down underneath there and you're tapping and you get to that rib, it's going to sound different than out in the open. Okay? So you have to, you really have to weigh the noise that you're hearing with what you're actually trying to inspect. Okay? But the easiest thing is this. Dull thud indicates damage. Clear ring sound indicates no damage. Okay? That's what we want to hear. We want to hear that nice ring. The next is backlighting. Remove all paint from both sides of damaged area and put a bright light on the back side. Okay? So this is where you grab your flashlight. Once you sand it down, this is what you guys will be doing. Okay? You're going to be removing the paint with sandpaper on the outside. If your thumb's not burning, you're not sanding hard enough to get that paint off, okay, because the friction caused by sanding will burn your thumb, okay, so you're going to remove the paint as far back as you think you have damage, okay, you're going to get your light, you're going to put it in behind there, and you're going to actually shine it, and you will actually see shadows where those cracks are, okay, when the light shines through, you know, when the fiberglass is perfect and where it needs to be, that light will shine through easily. When you get over to a crack, it'll turn into a shadow. You have to follow that to the end. If you haven't sanded back far enough, you need to keep on going with some more paint removal to make sure you get to the end of every bit of damage and have identified every damage that's in this part, okay? What that means, all paint needs to be pulled back on the outside, and you'll probably have to sand the inside because some of these wheel pants still have, you know, some gray primer and weird stuff in there. Don't mistake gray primer for shadows, okay? So it's important to remove all your paint as much as you can. Try to distinguish between, wait a minute, did I get all the paint off of there? Is that what I'm seeing? I'm seeing paint, not an actual delam situation, okay? So identifying the damage, okay? That's the main thing. There's also some other interesting things that you can use, which we don't have. You can use X-ray. The X-ray is good because water and honeycomb can be seen. Keep that in mind because that's one of your questions on your FAA thing, okay? How do you detect water in certain parts? You know, what are you going to use to do it? Ultrasonic frequency, high frequency sound is used to detect damage area. Thermography, neutron radiography, whatever you want to, however you say that. So these are all different high-tech things. Obviously, it's going to be very expensive equipment that someone is going to be, you know, entrusting you. You know, you don't drop it on your way out to the airplane type of thing, you know. Typically, the NDT boys will have all of this stuff, okay? So my son, when he works at Gulfstream, if they have a suspected problem, they pick up the phone, boom, NDT comes out, they do their little thing, because you can work as an NDT guy, and that's all you do, is you go out and you do inspections and you know, looking for problem areas, you know. They think they have a crack, boom, you're the guy at the NDT shop, gets called, they come out, they do their inspection, and so he can basically, you know, do his inspection on the airplane, whatever he's working on, he suspects something, he doesn't have to take it any further, he just makes a note of it, calls NDT, they come out and they verify, yes, that is a problem, no, that isn't a problem, okay? And they're the ones that are gonna be trained in how to use all this equipment. Okay, structural repair manuals. All composite repairs must be done in accordance with the SRM. Read the fun manual, okay? It's always fun to read the structural repair manual, okay? It always will tell you exactly what you need to know until you get to a point where it talks about, you know, a fastener next to a, you know, attach point and things like that, and then all of a sudden they start getting vague, okay? In my manual here, this is for a Grove. I was looking at it the other day, and it said, let's see if we can go to that. This almost got me in trouble once. Other way. Okay, so if we do, oh, that's gonna screw it up. I think you guys can read that at all? Let me hit the button. Is it not bad? Up here, it talks about major repairs are. Can everybody read that? Major repairs are. I do want you to pay attention to one thing. This is a structural repair manual. What kind of font does that say versus the actual instructions? Major repairs are. This is a typed in thing on top of a repair manual. In other words, this was, before this came over to the US, they added a bunch of different things. Okay? So repairs in accordance with the glider information sheet are only to be carried out by the manufacturer or an approved aeronautical workshop, because obviously in Germany, they don't know it's a certified repair station. Okay? Who has the authorization of the manufacturer in any individual case. So you can read an instructional repair manual and you keep on going and you're like, oh, I got this, I can repair this, I can repair this. And I got to the end of that and I realized that I couldn't repair it. When do you think I read that? After I repaired it. Okay? Because I got to the final end. I didn't read it all the way through. Okay? So at that point, I had to figure out what I needed to do to get this repair certified by a shop. Fortunately for me, there was a guy that lived over on the lakeshore that had been through a lot of the German schools, and he actually was one, I think he was the only certified person outside of the manufacturer to actually repair main spar for Alexander Schleicher. Okay? Which, repairing a main spar is actually fairly involved. Okay? You guys saw the wood guy talk about repairing main spars. You know, it's fairly involved. It's the same thing with gliders. This guy was an absolute magician with composites. Okay? There was so much black art that he knew about composite repairs. He would buy a glider that was completely demolished. I mean, the tail's broken off, the wings are in pieces, and he would take all these pieces and he would go into his basement in November. Okay? And then come March, he would start pulling out these amazing, beautiful wings and complete fuselage and everything. It was, I mean, the quality of work that he did was, I mean, I can't even describe how amazing it was. Okay? He can repair fiberglass in his sleep, basically. I mean, when I was first introduced to how really good he was, this actual glider that I was talking about, I had consulted him to do the repair. You know, not knowing that I was gonna have to go back to him and have him sign it off. Okay? He comes over to show me where, you know, we have these cracks and things down the side of the fuselage, and it's right up at the wing attach point. And he's like, yeah, you just wanna, you know, scarf this in there, and what we mean by scarf is putting an angle in the fiberglass. He grabs the whiz wheel, and he starts, you know, he goes, I'll show you. And so he starts scarfing the repair, and he's talking to me over here while he's scarfing the repair, okay? When we finally get to that, you will realize how amazing that is, because when I am scarfing a repair, I'm fully concentrated. I'm down there, I have a hand touching the part, a hand on here, and my fingers holding this so I can be as steady as possible to make sure that I am blending it exactly in the right chamfer, in the right everything. He was doing it full arm outstretched and talking to me at the same time. And it blew my mind, you know, because I can only do scarfing for maybe an hour and a half, and I am completely wiped because of the concentration it takes for me to make sure that that scarf repair is how I need it, okay? So, back to this guy. So, follow the instructions, read the entire repair. Don't do my mistake and see at the very end that the manufacturer typed in an additional little thing at the end saying, oh, by the way, no Joe Schmo can just go ahead and, you know, repair this. Alright, so surface repair. Okay. Obviously, if it's just a scratch in the gel coat, by the way, let's talk about how we cover airplanes. Most planes are going away from gel coat. Gel coat is a polyester resin, okay? that we apply to the outside, it fades over time. Okay? It crazes over time. It just generally has issues. Most new gliders are all polyurethane enamel painted, okay, because it lasts much longer. But boats, things like that, all have gel coat still, okay, and that gel coat, we're not gonna mess with gel coat, and if you ever mess with gel coat, it's a royal pain in the butt, okay? It takes a long time. I mean, you can do a good job, you can fix it correctly, it can look right when you're done, but it's kind of like the Kuhns egg guy. It's a black art, learning how to gel coat, okay, and do it well, and especially getting the colors to match. So scratches in the gel coat, no big deal. Pits abrasion with one or more layers of catalyzed resin, usually allowed for damage that has not entered the first fabric ply. Okay, these glider wings, to refinish a glider, $20,000 to put a new gel coat on. Okay, so said individuals that own gliders say, well, I'll just sand it off and have my buddy Dave there spray the new gel coat on and we'll be good to go, right? So they start sanding off their gel coat and they take it over to Dave. He takes one look at it and he goes, well, that's great and all, but you didn't save a dime because now you've sanded through the outer layer in 15 spots on each wing. Now I have to go in, I have to scarf in a new layer and fix every spot that you cut that fiberglass. Because there's only 2 layers on here. You can't compromise those layers. You've got to put those layers back in. So every dime they think they saved, they paid out again to have him go through and fix every spot. Okay? It's much like the guys that, they want to DA their airplane to get the, sand it out to repaint it, and they sand the rivets down with the DA. Okay? FAA says if the dimple is gone, it has to be replaced. Okay? That's where you get your center punch out and you recreate all your dimples, right? So, I've seen lots of airplanes that come in, the owner, he did his thing, and he got flat rivets, and you're just like, what do you do? Well, better give me a blank check and we'll solve this problem. Or you go away and have the guy that, screwed this up, redo it, But there's a lot of airplanes out there that I've sent away. I'm just like, I don't even wanna see your airplane again, ever, But they'll find someone to sign it off, cause they won't be as, I guess you wanna call picky or whatever, I don't know. But, I just wanna be able to sleep at night. So for damage greater than this, a mixture of resin and filler may be used, only if your SRM says you're allowed to. Okay, in the case of only two layers of glass, that's not going to happen. It will not say fill it with microblues and go fly. Okay, it's not going to say that. Okay. So, anyways, the surface repair is only for damage that does not exceed the first fabric ply. I'm pretty sure most of your damage out there exceeds the first ply. Okay. Damage extending into a laminate or face sheet beyond the first ply. I don't understand it.
We're laughing at your joke.
Oh. I didn't make a joke.
No, there was not a joke.
But in the case of a sandwich structure knocked into the core material can be repaired by two. Okay, so damage into the laminate or face sheet beyond the first ply, as long as it's not core material like this, can be repaired by 2 methods. A scarf, a tapered. The scarf ratio depends on the requirements, can be as low as 1 to 10 and as high as 1 to 100. In the FAA, in one of your questions, it talks about a honeycomb foil laminate thing, and they say what should should be the scarf ratio on that? And the answer is 100 to 1. Okay. Who all has a pocket knife on them? What on earth do you think your pocket knife blade ratio is?
150.
What's a razor blade ratio? A razor blade's pretty sharp, right? Who wants to Google it? What's the razor blade ratio? Well, you have to look it up. Who wants to Google what is the angle of the razor blade ratio? No, it's being it's like 1 to. Who can get it? Who can get there on their internet? It might be 4 to 1. That's not.
1610 razor blades.
That's Fraser gaming monitors.
It's not more than 25 to 1. Okay? And the FAA is requiring us to scarf our piece 100 to 1. Is that even possible?
Kirk said that in those situations, we can tell the FAA to go pound sand.
To go what?
To go pound sand.
Pound sand, okay, yes. Yes, this would be a perfect pound sand thing, because even though you can't pound sand when it's on your FAA test, by the way, because that question is in your FAA exam. Okay? And the answer is 100 to 1, which is dumber than rocks, if you ask me. Okay? Typically, we're 1 to 50 for composites, 1 to 80 for carbon, 1 to 50 for fiberglass, 1 to 80 for carbon fiber. Okay? And even 1 to 80 is pretty intense. I mean, you looked at those hockey sticks. I mean, when you get carbon fiber that's only a 16th inch thick, and you're supposed to go 80 of those all the way out, that is a very long slope. Okay? And somehow we can do it. We can actually get to 80 to 1, but I mean, 100 to 1 just blows my mind. Okay? So all our repairs are going to be about 1 to 50. Okay? So the thickness of your fiberglass was probably about yay big. So your scarf all the way around the outside of every crack is going to be roughly about 1.25 to 1 3/8. You're going to have to maybe do a little math, figure out, and you're going to have this little, pond. I call it a lake. Okay, so envision a little pond out in the middle of the field. Okay, and it's got a nice bank slope down to the pond. Okay, that slope is going to be a 1 to 50. Okay, and you need to make yourself this tall, stand inside that pond when you're doing your final grinds, and make sure that those slopes are perfectly smooth all the way out. Okay. Sometimes it's easier with carbon fiber to actually tell when you go through a layer and when you don't. It says use a sander to scarf the area. We'll be talking about that, but I'm going to give you this picture here. So this was a picture. I don't know what kind of airplane this is. This is showing you a couple different things. One, obviously, we broke the side of the fuselage just in front of the horizontal. Okay? So they're going in and they're fixing this. They've already gone in and they've put a Band-Aid on the inside, which is what you guys are going to do. They put a Band-Aid on the inside that basically just holds the form and holds everything in place so they can actually fix the outside. So in your appendix on your repair, all the way through step 4 is putting that Band-Aid on the inside. You're not even starting to repair your piece until that Band-Aid is on the inside. Once you get through step 4, step 5 you have to regain the contour. When that glider crash that we had, and we brought that guy from Germany, he comes over and he says, okay, when he's ready to start, he goes, okay, he sees the glider, he goes, where are all the pieces? And luckily, I had picked up all the pieces and thrown them in a box. Okay? I almost threw the box away, but I didn't. He then proceeds to take, once he built his little jig and he mounted everything up in there, he proceeded to take every piece and he put it back in every spot that it needed to be. He pieced that whole glider all the way back together, okay? Once he got it back together, he put an inside patch on the inside. He regained the contour of that piece, okay? If you spend more time in this zone regaining that contour, the end result, your end finished product will be, it'll take less time for the finishing because everything is in place. It'll be lighter. You won't have to add Bondo to smooth everything out and get everything where it needs to be. So if you regain that contour and get it back, and that's what he did. He regained that contour, got it all the way back to where it needed to be, and he used all kinds of really crazy ingenuity to, you know, piece everything together and glue it all back together and you know, to get it back to looking like a glider before he actually started the repair, okay? So in this case here, you can see in the fuselage here, okay, there's 1, 2, 3, 4 layers of fiberglass. Okay, now up here, remember we talked about we can add strength? There's another set of fiberglass piece, 3 pieces of fiberglass that run longitudinally down the side of this aircraft. And that's what these pieces are showing. Okay? So in other words, it's got the 4 pieces for the entire thing, but it has also 3 pieces running longitudinally to give it the stiffness and structure it needs. Okay? And so that's what you're seeing here, is in that picture, is you're seeing the fact that they're showing those pieces that need to go in there. So that's why I like this, is it's a really cool picture because you can almost see how this airplane was built by looking at their repair model that they put up there. Okay? We won't be doing quite like that. All right, so let's back up. We're going to spend the rest of the time looking at our pieces and parts out there. So if you go to your fiberglass repair procedures, step number 1. We're going to be working on step number 1 today. We're going to be removing the paint inside and out of the wheel pan by hand sanding. We are not going to be using whiz wheels. We're going to be hand sanding. We don't want to damage things because you guys don't fully understand the damage that you can do with a whiz wheel yet. We're only going to hand sand this stuff off. Some of you, most of the paint's been flaked off anyways by the first hit. I mean, I was brushing paint off me like crazy, showering everywhere. By the way, that's not good adhesion in the paint world, just so you know. If all the paint flies off on the first hit, that's usually says something about the prep on the paint. Use backlighting and tap test to determine extent of damage. Pretty much you're not going to use tap test, you're just going to use backlighting in this case. Okay? So that's where it's at. You guys, I think know where the sandpaper are, all the sandpaper stuff is. For the heavy paint, you're probably going to use 80 grit. What does it mean, 80 grit? Does everybody understand what 80 grit means? How many pieces of sand in 1 inch are in 80 grit? 80. Yes. Before we start, we need to count them. Okay, so that's what it means by 80 grit. Okay, so you're going to start with 80. You know, at least 80. I'd say 80. I mean, there's some 36 out there too. If you guys got some really heavy stuff, you might be able to try 36. You know, I mean, it was giving me the heebies thinking about those big belts because where I got that sandpaper, they had these belts this big, made of 36 grit. like, you know, I know, I was thinking, you know, it'd be good, you know, what if you fell on that? You know, what if you like slid across it with your knuckles or something, and just like, it would just remove absolutely everything off your knuckles. So I'd start with 80. If it's actually really thin, you can probably get away with 100. You know, and then you want to be careful not to get down too far into the glass. When it starts being transparent, that's when you know you're at the glass. Okay, and then you might have to bump it up to 100, maybe up to even 200. You know, just to get that final layer off there. And then get your backlight out there. Figure out where your damage is. Okay, so that's what we're going to spend the rest of the day doing. Hopefully everybody can get to that point where they can find the damage. Once you get to that point, we're going to halt because we'll talk about how we do the inside patch tomorrow. And then Monday. So once we'll talk about that inside patch, hopefully for the first little bit, and we'll be able to get everybody out there and actually figuring out, because we got to talk about how to the mixing table and all the other stuff as we get out there. So if you get done finding your damage, you can also then, there's plenty of illustrations up here of how to build bridges, so you can start your construction, pre-construction meeting on your bridge. And get with the engineers and see if it's approved. Right? Any questions?
Our bridges in the same groups.
Yes.
Do we have three rainers, like, are there dimensions for the bridges and do we have fairing for the designs?
Yeah, here, let's whip over here that's the inspection. Yeah, composite fabrication -12. Okay, so it's gonna give you, oh, he gave you the wrong. Okay, I'm glad you said something, because this is the wrong one. I spent a lot of time on the other one. So if you want, grab a pen, and I'm going to see if I can find where I okay, I'm just gonna give you initially, and then I'm gonna have them reprint the right ones. So you get one piece of carbon fiber, 17 by 8 inches. You get two pieces of fiberglass, one 17 by 17 and the other 17 by 8, or of one piece 20 by 17, whichever you want to figure out how to cut out. Max weight of the bridge, 150 grams. Okay, it can't extend more than an inch below the surface. Okay, it can't be above, but it can be below. Okay, much like all these things here that are showing how they go down. Maximum 1 inch. Okay, you can use all the pink foam you can use, you want. Okay, typically pink foam we use for, you know, it's the core, right? That's what we use. The dimensions of the bridge, let me see if we can find that. I think it's max 3 inches wide, okay? And then as far as the bridge, this is the contraption that we bolt to the table, and the bridge goes across here like this, okay? I would suggest you match drill these holes to this plate because they're not perfect, okay? And then in the very center is going to be a hole for a -3 bolt and a washer. Okay, so if you ever need to figure out if it's going to work for your thing, this is the stand. You can put your bridge on here. You can match drill these holes, figure out, you know, cause if you flip it this way, the holes aren't gonna line up, so you need to make sure you pay attention to direction, blah, 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 okay? But max is 3 inches wide, no more than 1 inch down, 150 grams, and you get those pieces of, fiberglass. So 17 by 10, excuse me, a 17 by 8 and a 20 by 17 piece of fiberglass. Those are the only materials you're allowed to use in this bridge. So as you go to your thing, and I'm gonna go try to find where the new one is, because 17 by 8. And for some reason I wrote, yeah, I think it's 17 by 8.
So make the top piece, just make the top piece of that.
That's all you get.
Okay. I didn't know what the top piece was.
Yeah.
Are they already cut out and stuff?
Nope. And we'll be talking about that later. We're not gonna be cutting fabric yet on that. We'll wait till probably tomorrow. Right now, it's all just design structure, excuse me, tomorrow, Monday. We'll wait till probably Tuesday before we start letting you, well, you might be able to get at it Monday. We gotta go show you how to cut stuff.
Bring your own scissors?
I would suggest, if you wanna, you know, go find grandma's scissors this weekend and bring them in. Those are gonna be the best ones. So. Alright, so you got, a little time here to go sand on your pieces. Try to use the downdraft tables. This will be the first time we fired up our downdraft tables. In the past, we've always had issues. If they're all plugged into the same circuit, it blows the breaker. So we're gonna find out if they're all on the same breaker. And we're gonna find out, get all this stuff figured out before Monday when we really start using them.
Two sheets of fiberglass kind of throw a wrench in my plans of how this is.
Go get, I think getting a nice. Yeah. All of the lights.
All of the lights. So David, how is it listening?
I think that's not a bad idea.
Well, the one that holds me best is this one. This one, that one, are the two.
Yeah, it's.
Oh, that's pretty cool. What's it called?
It only held 424 pounds. This one held 50 more pounds.
Yeah. This one?
Yeah.
There's almost like,
Yeah. And they didn't even bother with like full wrapping fiberglass on that. That's just foam and epoxy.
Well, it's fine with that. Let us foam on the inside.
Right, but it's not like lots.
I wonder how many layers this is. Just like 3 layers.
dude, that's pretty cool. I appreciate it.
All of the lights. It's crazy. This thing can hold me.
So yeah, I could, well, it might have failed already. But did
I still
already
have to
fail.
try and stand on it, just for fun.
Breaking the demonstration pieces.
These are last year's. This feels
Well,
terrifying to
I wanna,
stand on.
I wanna know which ones are strong.
This one's not the strongest, but it
Four
is,
hundred and 24 pounds, okay. Oh, yeah, it did break, you can tell.
yeah.
That's all right. What's the strongest one?
I think this is the one we agreed on the strongest.
What was that?
474.
474? Okay. Yeah, I see that. What's this?
53 pounds.
Okay,
Ouch.
so that has foam wrapped in the stuff, okay.
Yep.
But your pressure's gonna be over this way.
Right. 358 pounds.
53 pounds.
What
Yeah.
they do wrong. Well, you tell me what they do wrong. I have really like this was this one's 87 pounds.
Make sure you get your wheel pant done today, because you guys hopefully will get people laid up Monday, because we need to make sure that keep this thing going.
Yep, I'll get it. We'll get moving on it.
best design.
Mm-hmm.
I wondered about that epoxy powder coating right there. My old boat, I was always wondering what that was.
Mm-hmm. I think the best one that I've seen so far is this one.
It's a reading that.
This one. And I think this one, they like,
1717.
they extended their like thickness all the way to the ends, just barely. Like these ones, they really didn't overlap. This one's like barely, and then this, like it went super high and super low, super high and super low. They kind of kept it formed, I guess.
It's almost one piece.
Yeah.
Almost. More of a one piece.
Mhm. This one was at
1230.
I think.
This one's a 17 or ratio of 1717. Is that
Yeah, that one's 7 to 1.
7 to 1?
Yeah. Oh, this is an X. That's interesting.
Oh.
Filled at 200.
What did it need to hold up to again? Was it
Uh-huh.
a pounds or
Can't remember what exactly.
was it 1,000 something? I thought 1,000
Yeah.
inches. I guess we haven't really talked about this much. Trying to understand what we're actually doing. Foam on the inside.
Because I don't know if this one, it seems like everyone else is gonna do that great, but this one, I'm wondering if this one, I don't know.
I think they left it on the heat or something. Melted.
I don't know what's going on with this one, because I'm curious, because it doesn't say pounds, but this one says 53 pounds. So I'm wondering if these ones are better? I don't know.
Wonder if they melted some of this because it's too heavy. 126, 124 now.
Yeah.
They give it some weight.
Which one did he say was the winner last
There's
year?
not a whole lot of theory behind this one, but it broke right there. But I wonder what it broke. Do you remember the criteria for what it had to break at? What that minimum was?
I do not remember.
1,000 something.
I don't know, I'm trying to understand this one. I'm like, does it say that it's like, that's the pounds, or is it?
It's all jumbled up,
Yeah,
yeah.
I'm like, bro.
I don't want this one.
This one might be the best, but I don't.
No, that's the one we want right there, baby.
Yeah.
That's a nice clean break right there. They tried a different design.
I thought it was like I thought they just had like extruded foam or something on the bottom.
I mean, the
What
ribs
is
are
this?
the ribbing is important because that gives you strength because of
Right.
an arch, but you don't have to go so deep like these. I wouldn't think. Something more like what you were showing here.
Yeah.
Maybe a little steeper. I don't know. It just depends on how much material you get. I feel like we're cutting out pieces of foam and then we're covering it with fabric and resin. And then we wrap it around. Where the ends would be.
Right, because you said like the foam is the base, right? And then you just lay the.
I think it's important to like keep ours, like they did theirs. No, this one must have not passed because remember he said it can't extend. So if they,
Like it can't go out to the hole. It's gotta stop
yeah,
here.
it's got the hole's got to be the flat part, and this one that's not. So this one I don't think meets the qualifications.
So what was it on the bottom? So they just have like a foam piece and then they put it over it, like they laid it over or something? Because it is. I mean,
You
it's
have a
completely
you have a
hollow.
base of some sort. It looks unless you you layer fabric down, put the foam on top of it, and then
Yeah,
fold it
I
over.
See, I was confused because I thought he was
I
saying
said
that.
all I know is we can't do that.
I thought he was saying that like we were gonna like
That's just-
lay the lines
just foam.
ourselves,
Yeah,
but
insulation.
apparently we're not.
We're not what?
Now this is interesting.
Like I thought we were. Cause he was talking about how he was like he was gonna try twisting his because he wants to see if he can make his better.
Yeah.
And I was like, what do you mean twisting? Like this is like.
Well, is he talking?
I think this was one of
Is
the
he talking
strongest
about
ones.
Like twisting the layers
layers
of
or
the.
whatever?
Yeah,
Like
I'm
the
just
plies?
curious. Like what the
Yeah,
heck?
I
1796 to, the minimum was 1,000, correct. So we need to get it so it lasts till 1,000, we don't have to, overachieve. But this is an interesting design, because
Which one, what is it, that one say, what was it, what's the pound on it?
well, it snapped right there, but not till 1796 to 1.
I don't have good handwriting.
So what's interesting is
This one
that
is
they're
only
not,
50.
oh, and this one did.
And I also have a tendency
What's
to
interesting to me
miss
is
my
how
English because they're loose.
they're breaking in the middle. A lot of them are breaking in the middle. Like this one.
I pick what comes.
Well, you see, is this where the
Not
weight is?
pretty well. I
The
can
centerpiece?
read it.
Yeah.
Right, but it's
That's why they're
getting
breaking
supported
it.
by just.
Tim didn't
Yeah,
speak
how are
to
these
me
holding?
Well,
anything,
let's see.
It is.
so
Okay, yeah, that one did.
Okay, that was
Well,
not
and this
even
one has
close.
a solid weight. Because this one's light. So the ratio is a lot better.
See, this doesn't have much of an arch. This one broke early at 592.6.
Where did this one
582.6.
I'm confused. Oh.
That one's even high. But look at this, there's like no arch in here. The arch gives you strength. And they put no arch in this one.
Yeah, that must be it.
Because this is 582.
Yeah.
0.6, not even close.
Strands in there.
Not judging.
This was Leo.
what he was talking about.
That one was the best one, that's the one you said.
Yeah, but like.
I don't understand how we do that. Because you have to get it in between all the fibers before you twist it.
What's the ratio on that
Keep
one?
the 60-40 ratio, you have to get it in between.
This one
It's
just
not
barely
just
made
the
it.
one-
What's this
That's
one
per one strand.
one's a
You can't
1,000.
twist it without.
1,717.
I would like to trade in my body.
Oh, this one's even
better.
Yeah, I like the idea.
That's the strongest one.
I like that.
I think. I do too. Yeah, because it needs to be 1,000 to 1. 1,000.
I like how too there's just that one.
I'll be researching it over the weekend.
That one's impressive because it's quite a bit lighter.
My brother's in
It still carried a little more.
engineering
It's a
for
structure.
cars and he's really into the carbon fiber.
This one just barely
stuff,
made it.
so
Perfect.
I don't know if he's gotten to that class yet.
What's
Yeah.
the weight?
But
What was
we
the
can see what he has.
It's the ratio he was
The
saying.
ratio.
They don't have a
I'm not sure how you determine the ratio.
Yeah, they made it the thinnest at the
What do you
center.
mean? How
Of
they
course, that's
make
gonna
it thin?
snap.
I know it's 1,000. One is a little bit wider. How do you determine that ratio?
ratio is what it snapped at versus, but it carries.
The weight?
Versus the weight of the actual bridge. This was 4
Weight of the bridge versus what it snapped at.
So there's a higher ratio
That makes sense.
because it's lighter.
I think technically one isn't silly sauce and love sauce and Mr. Love.
I think these are the top two.
It's cheeseburger. Come on.
Oh, what about the manatee?
Barbara Manatee.
Oh,
Oh, you mean like on the end? So what if there's another ring? Oh, you're saying like this right there. You want something like this,
Good one,
right?
right?
Is that what you're talking about?
I mean,
This was the best. There's the highest ratio.
Oh, where there's a little peak in
And this one did carry the most weight.
I mean, the snap rate is much more aggressive.
Ratio, but the
Because once it gets past that point, it's gonna go.
foam covers.
But it should be able to hold more pressure. Say,
Is there fiberglass
But
with
they're not gonna listen to that.
on the thing.
different directions or one direction like
And then you
that?
give them the hair pressure, it's like, I found it.
But I don't know if there's a way that we can.
Yeah, but
Cause it, what if you do this design and then put triangles in them? That'd be complicated. Oh, it definitely would be complicated, but what I would do is I would do that first and then lay this piece on top. That's how you.
well, I was thinking about
no
those,
ratio.
the
They still haven't broken yet, so they don't
ramps
know
up
where
there, car ramps. They're kind of honeycomb on edge.
honeycomb is a good shape.
They don't have to hold anything suspended,
Yeah.
but
The honeycomb is facing up towards whatever your weight is. So for us,
Yeah, actually kind of.
if we're trying to
No, it ain't so. I think
keep weight from going this way,
right.
I guess it would.
I was thinking of having it on its side like that T is, like the upright of the T is. I don't know, it's awesome. I don't know whether you could put anything on the bottom.
Because the honeycomb on the sides.
No, no, the honeycomb,
And then they would.
the edges, the edges of the honeycomb are
That is
and then have a piece across the bottom.
Okay.
I don't know whether that
Oh,
would
I
help,
see what you're saying.
or whether it would just collapse the ring itself.
Yes.
In the middle of the side.
21?
Yeah.
Oh, it is good.
Would be kind of complicated.
I think it would be worth trying.
Hey Isaiah,
That's a good
I'm
idea.
gonna do some research this weekend. You do some research.
You just have to
come
figure out how
back,
to make
We'll mesh minds.
type of shape.
see word book. What is that called?
their sheath